Imagine this, you're sitting under a tree. Suddenly, an apple falls beside you. This moment seems ordinary today, but over 300 years ago, it sparked a revolution in science. Isaac Newton asked a fascinating question. Why does everything fall down? Why doesn't the moon fall on us like that apple? He wondered if a hidden force was pulling everything toward the Earth. Newton connected the falling apple with the moon's orbit. He proposed a groundbreaking idea, gravity. Every object attracts another. The strength of this attraction depends on mass and distance. Newton provided humanity with a tool to calculate and predict movements in our universe. With his law of gravity, the movement of planets started to make sense. Scientists applied it for navigation, tides, and predicting Halley's Comet. The universe appeared like a giant clock operating under clear rules. But science thrives on testing its boundaries. Over time, some issues cropped up. Mercury's orbit didn't match predictions exactly. Some guessed there was an unknown planet. However, evidence was slim. A piece of the puzzle was missing. Then came Albert Einstein with a bold new idea. What if gravity isn't just a force? Instead, what if it's related to our perception of space and time? Imagine space-time as a flexible fabric. Large masses, like the Earth or the Sun, bend this fabric. Objects follow these curves, just like a small ball rolling around a heavier one on a stretched sheet. In 1915, this vision became known as the theory of general relativity. But how could we verify its truth? One of the first tests occurred during the solar eclipse of 1919. Light from distant stars bent near the sun as Einstein predicted. This was proven with photographs, making his theory famous around the globe. Relativity solved mysteries which Newton's law couldn't. Mercury's orbit made sense. Suddenly, black holes, regions of extreme gravity where even light cannot escape, became a reality. Later, scientists even detected gravitational waves, tiny ripples in space-time caused by colliding black holes, just as Einstein anticipated. Gravity plays an essential role in our daily lives. GPS satellites rely on corrections from relativity since time flows differently in orbit than on Earth. Without this understanding, our navigation systems would fail. Grasping gravity helps us launch spacecraft, study climate, and explore the vast universe. However, the story doesn't end here. New mysteries arise, including dark matter and dark energy. Most of the universe appears invisible, but its influence is undeniable. Is our understanding of gravity incomplete? Or does the universe hold unknown ingredients? The search for answers continues. In the end, everything began with simple curiosity. Why does this happen? A falling apple ignited a new way to see the cosmos. Perhaps one day your small idea could spark the next significant chapter in science. From Newton, watching an apple fall, to Einstein bending space and time, we have learned that reality can be simpler than we think and stranger than we can imagine. Curiosity remains the driving force that propels us forward. Now that you've learned about the journey of gravity, why not share your thoughts in the comments below?